Alrighty. We are live. Hello, everybody. I hope everybody is doing well tonight. We are going to pick up where we left off on the last stream with our material system resource updates that we're making. Before we jump into that, though, I am just going to take just a quick second just to thank the supporters of the channel. Listed from the top there, starting with our elite partners, which is the highest tier of subscription over on Patreon and YouTube memberships. That is Javier Olazaran. Javier Olazaran. Sorry if I mispronounced that. So that is our first elite partner. So thank you very much for your support there. I would also like to call out our partners Furkan Tokan and Gerboles Inc. They are the sort of next tier of partner on the YouTube memberships and Patreon. In addition, I would like to thank all the other supporters who are listed on the screen. They are a combination of the other tiers of support on YouTube memberships, Patreon, as well as Twitch subscriptions. So thank you all very much for your support. It is greatly appreciated and helps me cover expenses with hosting and project licensing fees, things like that, for the software that I use to develop and edit, etc. So thank you very much for your support. I would also like to thank all the supporters who are the viewers here on the channel as well. Whether you're catching us on the VOD after the fact, or whether you're joining us here live, either on the YouTube side or the Twitch side. We do simulcast to both, so with that said, this is meant to be an interactive stream, so obviously without you guys here, this project would not exist. So thank you all very much for being here, and like I said, this is an interactive stream, so if you have questions or just want to say hi, feel free to jump in the chat and do so. Let's see. So, over on the YouTube side, says, sorry for asking this, but is it possible for you to start streaming earlier? Unfortunately not. I do work full-time and I have other responsibilities, that come with, home ownership and things like that and having a family. So I'm not able to start any sooner, right? This is sort of the time that I have allotted to do this. So, yeah, unfortunately, that's just the way it is, If this ever takes off to the point where I'm able to do it full time, then that would change, obviously, but I don't see that happening anytime soon. So, RCW, hello, how's it going? Good to see you. I am well, how about you? Thanks for joining. All right, so let's see, are you working on the game yet or still prepping? So we still have some engine stuff that we're doing first that I want to knock out of the way. So we have our texture resource work done. We are in the middle of the refactor for materials, which is sort of the next most complex thing in that list. After materials will come meshes, which will be even less complex. And then from there on, all the other resource types are going to be fairly trivial to copy over or to refactor to use the new resource system. So we still have a little bit of work to go before we can actually start on the game. In addition, we also have a few features that we want to get into the game. Let me pull up the design document because we actually did list some of those things. Let me just grab the right document here. Yeah, so here we go. Let's pull this down here so you guys can see it. So all the way at the bottom of this document where we are kind of putting some things, we kind of have this section of things that we need to do. However, we don't need to do all of this stuff to start on the game. Some of this we can kind of do in the middle. So things like the post effects, that can wait, right? Emissive maps, that can also wait. HDR tone mapping, that can also wait. Particles we're probably going to need to do at some point, but it can wait. Same with static mesh LOD. Animation system is probably going to be something we're going to have to add a little bit into development, but it could probably wait, right? Resource streaming, I'm not sure if we're even going to need that for this first game, so maybe not. That's why there's a question mark there. Same with spline editor and controller support. So we do have some things that we need to add to the engine after what we're doing here, but I don't think any of it really blocks us being able to start in the game. I think what we'll be able to do is at least start getting a prototype together and get something playable, with just, programmer art and blocks and stuff like that to make sure it's fun. And then once we start actually working on the visuals of it, then that's when a lot of this stuff is going to have to go in. Let's see. Doing some great work. The engine is the main priority. I appreciate that. Yeah. And I'm trying to take my time with it, but not too much time, right? I want to make sure that it's right, but at the same time, I don't want to spend too long on it. Let's see. Speaking of refactoring, I'm currently refactoring my game logic code, which is always messy, so it's overwhelming. How do I be less overwhelmed by refactoring? Refactor smaller bits at a time, right? Oh my god, it's the guy from The Thing. Big fan. What thing? I appreciate that, but yeah, what thing? Let's see. How do I find game levels to test my engine? You make them. You don't really find them per se. You make them either with a model editor like Blender, or you build a world editor into your engine, right? It's not usually something you find. You can use test assets to help you build that, but you're horrible at 3D modeling. Yeah, so you could buy them, There's all kinds of places to buy them online. You could just look for, 3D models for sale. Just pay attention to the licensing when you get that. Let's see. Doing well. Made some progress on my engine. Allocators are done. Nice. Those can be tricky to get right. Doing lots of research on engine design and thinking of next steps. Yeah. And that's a process that you could spend a lot of time doing, for sure. I know I certainly spent a lot of time thinking about it before I started this engine, and still wound up changing a lot of stuff. So that's kind of the reality of it, right? Okay. CG Trader, yeah, is great. I've heard of that one. Yep. Also, Open Game Art has some free resources too, if you're looking for that. Which is probably what we're going to do for some of our placeholder stuff, right? Because it doesn't need to be pretty, it just needs to be in there and working. Apotham, good to see you. Welcome. Hope you're doing well. I suggest Kenny LL for free models. Yeah, I always forget about Kenny. Yeah, for sure. Kenny's a good resource for sure. All right. So let me just refresh my memory, because when we left off last week, we were kind of in the middle of writing our resource handlers for our material, which I think we might have actually completed. And I haven't actually had a time to touch this off stream at all, unfortunately. So I just kind of have to play a little bit of catch up here. But I think this is where we left off. And then I think we were maybe talking about how we were going to combine these texture maps, if I remember correctly. Yes, that's what we were doing. Okay. So in our materials, we have a concept of a sort of combined map right now that handles our metallic roughness and AO maps, right? And in the material shader and all that other stuff, we call it combined map. We're going to rename that to metallic roughness AO. And we're creating a texture here that's going to be sort of that combined texture. And the way we're going to do this is whenever we load one of these image assets, right? Which is either going to be a metallic roughness or an AO image. We're going to keep track of which one of those are loaded. We should probably keep track of also which ones have been requested. And then from there, we will say when we have everything we need, we will build out the or upload the data for the combined map, or the metallic roughness AO map, based on the data from those images, or the default of it if it's not provided. So we could have a situation where maybe none of them is provided for that particular material, right? In which case we would just grab the sort of default combined texture that we have in our texture handler. But let's say that we want to, for example, provide a metallic map and a roughness map, but maybe not an AO map, right? Which is going to be a pretty common scenario. Then we can provide, those two assets, and then pull the AO asset data from the default AO image that we have in our texture system. So we can kind of mix and match those. And our listener should sort of be a little bit aware of what all we have requested. So it looks like here we actually had set up a MRA listener, which is metallic roughness AO. And we have a target map, a channel, which tells us what channel it is, and the actual material map itself, right? Sort of the configuration that goes along with that, which is good. We pass that along as sort of our listener context whenever we request one of those assets. However, we do not actually have everything we need, right? Because technically speaking, we need up to 3 of these structures, right? So realistically, what we need is we need a structure to wrap this, and that should actually be the listener, right? So I guess we can keep this as listener, but let's do typedef struct. And we're going to say material MRA data, right? And we'll do material MRA data. Tacers, thank you for the follow. I hope I pronounced that correctly. Let's see. Watch videos of you sporadically, but there's just so much, and I haven't had the time to dig into that level in years. Still love seeing the endless dedication. Awesome. Well, I appreciate that, SX. Really appreciate that, and thanks for being here. Let's see. What is the language that we're programming in? We're programming in C. All right. Mean Mr. Mustard, good to see you as well. How are you doing? So we're going to take these properties and we're going to put them in here. And we're going to eliminate this and instead do material MRA data. I could do an array of these, but I think just to be explicit, I'm just going to separate them out into different values, right? So we're going to say metallic info, right? And then we'll do one for roughness info, and one for AO info, right? And then that way we can actually determine what we're dealing with. So let's see, each one of these probably should have a state too, right? As to whether or not it's loaded. Whether or not it's loaded has even been requested, etc. So I think probably the easiest way for this is just kind of typedef enumeration rather. And we'll just say MRA status, or I guess we'll say state. Right, and this is going to be all private to this file, right? So it's all statically used within this compilation unit. And so we'll say MRA state uninitialized, I guess. So we'll do MRA state requested, right? And MRA state loaded, right? So the way that this is going to work is we're going to have 3 potential states for each one of these MRA datas, right? So we'll have MRA state. And this will tell us whether or not that particular slot is even used, right? If it's uninitialized, that means it's not used. If it's requested, then that means that a request has gone out for it. And let's see. There's 2 parts to this, actually. Do I want to keep the state separate? Magetsub, how's it going? Good to see you. Dr. Elliott, good to see you as well. Welcome, welcome. All right. So this listener is kind of going to be sort of our management object, if you will, for each one of these things. But we also need something to pass along. I guess we could, in theory. You know what? It would be simpler to actually do this as an array, because then we can iterate it, right? So let's just do let's do map asset data assets, I guess. Sure. Right, and this is going to be an array of 3. And we'll do type def enum MRA, and we'll call this indices, right? And we'll do MRA index metallic is 0, MRA index roughness equals 1, MRA index AO equals 2. All right. So we'll have, basically what we'll do is every time we get an image loaded, we will take the image listener for that, or the listener for that. We'll loop through all of these map assets and say, hey, are all of these either loaded or requested? Are either loaded or uninitialized? And if so, then, well, actually, I guess technically speaking, let's see. Yeah. If all of these are loaded or uninitialized, right, then we know that we're actually done loading all the assets we need. Because the second that we trigger an asset load, we're going to say requested, right? And so the way that this is going to work is every time an asset comes through here, it will immediately be marked as loaded first. And then it will, once we check and we have all of the assets loaded that we actually need to perform the combination, then we'll go ahead and do all this stuff. But there won't be a texture created until we do that. And so if we actually go to request that texture, we'll wind up just having to use the default instead, which I think should work just fine. That makes sense in my head. Let's see if it makes sense logically speaking. Okay, so I guess when we go to request this thing, The first thing that we're going to have to set up is down here for the request, right? So we're going to have to do, we are not passing, How do I want to set up the listener for that? Right, because we're going to have, let's see, we go through, I guess we can do it up here, right? So when we go through processing the PBR material, for example, we're going to have this listener type, which is, what do we call it? Material MRA listener, right? So we'll do a material MRA listener. I guess we can just call this, wow, if I can spell, we'll call it listener instance, and we'll do a 0 for that, right? We'll initialize it to 0. And so the reason that we're going to do that is if we never request a metallic map or a roughness map or an AO map, then we don't actually need to allocate this, right? We only need to allocate this if we have one of those 3 maps, right? So what we can do is, since these are all requested at once, we first check to say, well, if not listener instance, then we go ahead and allocate that, right? So we'll say listener instance equals kallocate size of material MRA listener. And memory tag is going to be, we'll do it under resource, right? So we'll go ahead and do that. And then we'll have to fill out listener. Let's see, listener I think is right before this callback, I believe. Yeah, it's right after auto release, right? So we want to pass along listener instance here. But then we'll also need to fill out some of that information, right? So we're going to say, in this case, listener instance, map assets, sub, MRA, index, metallic, right? And we'll do, let's see, k-asset material map. I guess we'll do the, you know what, let's grab a convenience pointer because I think we're going to have to set a few things on this. Right, so this is a material MRA data. And we're going to take the address of this, right? And then we can just say, you know, M state equals MRA state requested, right? And so by flipping that flag immediately, when we go to examine the actual results of the asset system request, we'll know right away if everything is loaded the way that it needs to be. What we should probably also do, since this isn't yet asynchronous, I'm thinking about race conditions here, right? So even when this is asynchronous, right, this asset system request, what happens if we haven't finished flipping these flags before we actually make an asset system request, right? I think what we probably need to do is queue these up, queue these resource requests up, and then request them all at once after we've actually flipped flags, right? So in this case, we'll do something like M. Let's see, K asset material map. Channel. Do we need channel anymore? Do we need channel anymore? Map channel. Metallic. I'll set it now for anyways. I don't think we are going to need channel anymore because we have this. Singy, how's it going? Hello, welcome. Target map, right, is also going to be equal to that. Right, so I guess we can just say, let's see, target map, which we're not even using target map in here yet. So I guess we weren't completely done writing this code. But now we have that in the listener instance. We don't need that there. So the only other thing that we need, okay, asset material map. So M, let me think about this for a second. This should be a copy of maps sub I. Right, so realistically speaking, we should probably do this same logic for all of these maps before we actually request them, right? So I guess what we could do, the only things that differ are these two guys. So technically speaking, I guess what we could do, let's take this logic, move it outside of the for loop, which is here, right? And say if listener instance, I think I need to add a scope here. Might fix all the weird tabulating I'm having here. All right, so if we have a listener instance, then we'll do for u32 I equals, oops, I equals 0, I is less than 3, plus plus I. Right, and then in that, we'll essentially do this. So essentially what this means is perform the actual asset requests for the combined metallic roughness AO map. We're gonna have adds here in just a second, right? This must be done after flags are flipped because this process is asynchronous and can otherwise cause a race condition. Just in case I ever look at it later and go, why did I do it this way? All right, so a map is just going to be this. Wait a minute. Oh, I actually don't need... Oh, shoot. I'm going to have to cache off these things in this data to make that work, which is not a big deal. Looks like we have ads. So for those of you who are new to the channel, we pause the stream on ads so that nobody misses any content, right? So I would suggest that you hydrate in the meantime, as I am about to do. Almost done with the ads. Got another 30 seconds and then we should be done. See, man, it's annoying trying to debug my sandbox application in RenderDoc, but the app window just flashes and closes. But when I debug it with VS Code, it runs just fine. Oh, I just said a bad word. So more than likely, I'm guessing that means that you've probably got a race condition somewhere, is what that sounds like. Because if your application runs fine when a debugger's attached, which generally means it's going to be slower, then that means that the debugger is slowing it down enough where you're not hitting that race condition. If I had to guess, it's probably something, if I had to guess, with well, wait a minute though. It could also be that you're using an extension that RenderDoc doesn't support. So check that too. Because there are Vulkan extensions that RenderDoc doesn't support. And if you're using one of those, then it will crash. So it could be either one of those things. But yeah, it's either that or a race condition having to do with the way that the window opens and swap chain recreation. And if you're doing that too many times, like in a tight loop, that could be bad. Ask me how I know. Okay, so we need to also cache the image asset name and the image asset package name for each one of these, which is not a big deal. So let's go ahead and add those here. Those are K-names. So we need image asset name and K-name image asset package name. All right. And then what we can do is just take these, put these here, and then say m image asset package name equals that, and then m image asset name equals map image asset name. Right, and then down here we'll just have let's see, did we actually... We did not. Just say this, the address of listener instance map assets sub I. Right, and now we can just say that. Okay, so I believe that is everything that we need. We don't have any sort of import params, so we don't have to worry about that. Okay. So, I guess the real question here would be, because the only actual difference between all of these is really just this. Well, and the index here. Okay, so I guess we can combine these cases, right? And then just do a quick if check down here, I suppose. Seems kind of gross, but so is repeating all this code. So let's just do that. We'll do case, k-asset, material map, channel, roughness. And then case, k-asset, material map, channel, AO. Right, so all three of those cases. We'll first do a check to see if there's a listener, create it if not. And then I guess what we could do is we could do a U32 index equals MRA index. I guess we'll go with metallic first by default, right? And we'll say switch, and we'll do map channel, copy these again. Difference being, we'll have a break for each one of these this time. And we'll do index equals MRA index metallic, right? Which I guess we didn't really need to default this, but whatever. Right, and then we'll just do roughness and AO. And it's only ever going to be one of these three, right? So we can safely just say default here to get rid of that warning. And then the other thing that we're going to have to change is the channel, right? So this is a k-asset material map channel. So we'll put this up here. Right, I guess we could just do this, honestly. And so in this case, channel is going to be k-asset material map. Wait a minute. I don't even need to do that. Wait, that's the same type, isn't it? Material map channel. Oh, what a dingus. I can just do map channel. Okay. So I really only just need this then. Get rid of that. And then this just becomes index. Okay, good enough. I'm okay with that. Why is this spaced weird? What am I missing here? So, oh, because I have it inside of the wrong switch. So this needs to be moved up, right? Wait, no. Oh, because this one has a block on it that it doesn't need. There we go. Okay. So, we set up all of those for each one of these channels, and then fire off the asset requests, right? Okay, so that section's done. Tom Marks Talks Code. Thank you for the follow. Appreciate that. Welcome. Some people love object-oriented programming. Some people love functional programming. Today, for whatever reason, I love the good old DOP, Dingus-oriented programming. Yeah, Dingus-oriented programming is strong with me today. Just to keep it family-friendly. Yes, exactly. Yeah, we can't be discussing OOP on here too much, right? We got to keep it family-friendly. We can't, talk about that one editor that we have to, do this to. The old VS. Let's see. First time chatter. Let's see. I'm a simple man. I see a fellow Arch NeoVim and I follow. I appreciate that. Thank you. Yeah, I quite like this setup that I've got here too. It works pretty well. Arch for the win, by the way. Okay. So we set up our listener instance. We fire off the asset requests. Then over on this side, we can then take this listener and evaluate all of its maps and see if the maps are all indeed loaded, right? So the only question that I have is, well, I guess we could test the asset to see if that's the asset that we actually loaded, if it matches that particular channel. That's the only thing I have to figure out how to match up. Well, I guess it would be the first thing we'd have to check is the result, right, to make sure it's a successful load. So that's actually going to be the first thing. So if result asset request result success, then we can do the thing. Otherwise, we're basically just going to ignore it for now. And we'll say else asset failed to load. C logs. Oops. C logs for details. Wow. Butchered that. Okay. Rewritten this function 3 times, just revert back to how I had it originally. Yeah, I get that. That's the old dingus-oriented programming for you. I do it live all the time. It's sus if I start RenderDoc with GDB, then run in my sandbox. The sandbox keeps running now. So wait, if you're debugging RenderDoc with GDB, and you run your sandbox from RenderDoc, which is being debugged by GDB, then the sandbox runs? That's a race condition then. Yeah, the only other thing I could... Yeah, it's not a unsupported extension then, because you would hit that error. So yeah, it's got to be a race condition then. More than likely, you are probably trying to do something like... because I know a lot of windowing APIs, when you create the window, it also fires off a resize event. And if you have your swap chain recreation tied to a resize event, if that happens more than once very quickly, that will absolutely screw things up. So, yeah, that's what it sounds like. What's the obsession that people have with hating on it, on the good old VS? No, it's a joke here. I actually use it as my debugger. It's just funny to bleep it. That's all. I mean, to be honest, I used this for a number of years before I actually switched to NeoVim, and I just like NeoVim much more. than I ever liked VS Code. But truthfully speaking, like I actually have a setup in this project to work with that editor because I know a lot of people use it, right? So, it's there is not really a good NeoVim debugging setup that I found. There just isn't, right? Especially cross-platform, right? Because it's not just a Linux issue, right? I need a consistent debugger on Windows, Linux, and Mac. You just raw dogs GDB CLI. I mean, that works for small applications for me, but like for something the size of a game engine, that's tens of thousands of lines of code. I don't have time to be setting that stuff up all the time. Yeah. Let's see. I use it for serious professional work, and I'm as fast, if not faster, than many people I see trying to hyper. Yeah. So I'm forced to use it at work, actually. Just because that's the setup that we have, right? So my rule on that is use whatever you're familiar with, right? I prefer this set of tools because I've learned to be decently fast and efficient with it. But if I don't care if you're using Sublime Text, right? Use whatever works. Use whatever you're familiar with. He uses Sublime. Ginger Bill uses Sublime. Yeah, I mean, a lot of people do. I used it for a bit. Let's see. So what have you done today other than swearing live? Have you forgotten it's an educational stream? Yeah, I know. I just we usually bleep out the name of that editor, but I was trying to be serious for a minute. But yeah. Keep it family friendly, yeah. I'm basically just trying to figure out the best way to, request the metallic roughness and AO maps, assets rather, and wait essentially until I have all three of them come in from the asset system, and then when I have all the maps that I need, at that time I'll create the sort of combined texture, load in the data, and handle all that. Me coding in wingdings. Oh. That would be infuriating. That would be almost as infuriating as this language, which I'm not going to say the name of, but I'm going to bring it up on let's see. This language. If you guys have ever seen this, that's what it's called, right? But yeah, this is the 8 commands for the language. If you guys haven't seen this, that's it. Yeah, you did get it right, me, Mr. Mustard. Yep. Yeah. From coding in wingdings to me would be even more infuriating than that, I think. Whatever makes you productive. Exactly. Yep. Exactly. All right. So when the asset comes through, we could, we could go off the image asset name actually, because the asset will have that, right? So, what we'll do is we'll loop through. We'll loop through the listener's map assets, right? So I is less than 3 plus I. And we'll say if, actually, I guess we should probably do material MRI data pointer. And we'll do, I guess, M equals address of listener map assets sub I. Right, so we can say if M image asset name equals asset name, right, which is just a K name. um, then we can go ahead and flip its flag to loaded, right? Because we already know we have a success here. So we can say m state equals MRA state loaded, right? And technically speaking, we can actually break that loop, right? Because none of the other assets are going to qualify under that, right? So we have that. And we're probably going to need to do some extra work, like all this. I guess, let me think about this for a second. I guess that's the only part we need to do, right? So, test for which asset loaded, right? And then we'll need to actually do this. We'll need to do this one more time. We'll need to loop one more time, actually. But the reason is going to be different, right? So this time, we're going to say, if m state equals MRA state requested, right? So if any of them are still in requested state, then we can do a k-trace for now. Still waiting on asset. And we'll go ahead and do this. Thank you for the follow. Appreciate that. And in here, we will do m image asset name. And we'll need to get the string value from that. So kname string get. All right. And then at this point, I believe we can actually boot out, right? So we can actually return, right? Because this means that we're still waiting on one of the three assets to load that has been requested but just isn't loaded yet. If we get all the way through this loop, that means that the state of these are all either in uninitialized, which means it was never requested to be loaded in the first place and isn't used, or they are all loaded, or some combination of thereof, right? So either one of these is fine. It's just as long as we're not waiting on one, right? So we'll just say boot if we are waiting on an asset to finish loading. Okay. Now we're on to the part where if we get this far in code, then that means we have everything loaded and ready to go. This means everything that was requested to load has loaded, and combination of asset channel data may begin. Okay. So, let me think of the way to do this. So essentially what we're going to do is, in the order of metallic, roughness, and AO, we are going to use one channel of data. We're going to use the red channel out of each texture, right? And we're going to say, or should we? Yeah, I think we're going to use the red. We're going to specify the red channel out of each texture, right? So we're going to say take the red of the metallic texture, the red of the roughness, and the red of the AO texture, right? Or image, rather, I should say. And metallic is going to be put into the red channel of the combined texture. Roughness is going to be put into the green channel of that texture, and then AO is going to be put into the blue. And then for any of those that don't exist or weren't requested, we're going to use their default instead. So I think I can actually accomplish this with yet again another loop. So we're going to do that. All right. And what we're essentially going to do is we are going to loop through the image data. Oh, you know what? Do we actually store off this asset data anywhere? I don't think we actually do. We're going to need to do that. Yeah, we need to do k asset image asset, right? So whenever this loaded thing occurs, we're going to say m asset equals k asset image asset, right? We're going to keep a convenience pointer to that as well. Okay. So the first thing that we're going to need to get is we are going to need to get dimensions out of it, right? Because that was one thing that we are missing when we go to create the actual image down here, right? So we're going to need U32 width and height, right? And we'll say if I equals 0, then we're going to say width. Ooh, you know what? We need to... there's going to be an issue with this, actually. There's something I didn't think about. We can't... Okay. So, in the event that we have a material that doesn't have default data specified for it, we're not actually going to be able to just use the default material data for that. I'm sorry, the default image. So we have this concept of like a default AO image, a default normal map, a default metallic, a default roughness, all that stuff, right? We have default images, right? But those are of a certain size. I think they're 16 pixels by 16 pixels. In this case, these assets could be any size, which means that we actually are going to have to figure out what the size needs to be and then generate that amount of data in that particular channel, right? Because it could be anything, really. Odd Oculus, raided with a party of 25 viewers. Thank you so much for the raid. How are you doing tonight? What did you get up to on stream? Let me give a shout out. If you're not following Odd Oculus, definitely do it. He's making a really cool game on Unreal. And it's really coming along nicely. I really love the way that game is coming along. Working on in-game UI, but you wouldn't tell because it's all C++ refactoring. I get that. I totally get that. I've been doing refactoring here too, so you can't see any of it. So I totally feel that. So for all of you raiders, I will give the quick and dirty introduction here for everybody that's new. Welcome, raiders. So what we are making here is called the Kohi game engine. So this is a sort of an educational series on how to build a game engine. We're building it from scratch using C and using Vulkan as our initial rendering backend. I say initial rendering backend because we intend to also support Direct3D and Metal. And it started off as a YouTube tutorial series, and then we changed formats a few times and ultimately landed on the live stream format that you see here. So we try to do as much as we can on camera, and the whole idea here is it's going through the process of building an entire game engine. from the ground up, and you know, trying different things along the way and seeing what works, what doesn't work, things like that. It's kind of the resource that I wish that I had when I was learning how to do this stuff. And so there's YouTube and Twitch links here. This website actually is right there. I'll drop that in chat. And so this engine is free and open source. So if we click here, we can actually go over here to the GitHub page where you can see the actual engine here. So it is Apache 2.0 license, which means that there will never be any sort of licensing fees or royalties of any kind. It'll always be free. It'll always be open source. And so these are some screenshots. I can't currently run it because I'm in the middle of a refactor right now, but these are somewhat old screenshots, but we do have a basic PBR lighting setup with cascading shadow maps and whatnot. So we still have a long way to go on this, but you know, we've built everything that you see here from scratch, including our UTF-8 font rendering and things like that. So let's see, there's that. And then there's a bunch more links on here. Again, our YouTube, the Twitch, a Discord server, which is at about 1,000 people now. And then GitHub and Patreon if you're interested in that. And basically what we are doing is we are gearing up now to build a game which we have been kind of starting to build a design document for. So we're basically going to make a sort of endless runner style game, but I put that in quotes because it's a very loose definition of it, where you're going to have the player piloting some sort of vehicle, right? And there's going to be melee and ranged combat in it. There's going to be flying, underwater, you know, surface-only vehicles, stuff like that. You'll have lanes that you can change into back and forth, horizontally and vertically. And so, you know, we've got basically some of the things for like vehicles and stuff spec'd out. It's going to be a little bit like the old game Road Rash 3D, right? So that's kind of one of the concepts that we're going for, and or the old Final Fantasy VII Escape from Midgar motorcycle scene, right? Obviously with a little bit more updated graphics. So that's what we're looking to build. We're thinking of, you know, in terms of visual styling, something like, you know, retro futuristic, but in the style of sort of a cartoonish type of style, like a mix between that and like Borderlands, in terms of that. And then we've got a small list of features here that we need to put in, not all of which need to go in before we actually start the game, but we do have a small list of those things there. And what we're in the middle of right now is a refactor of our asset and resource system. So resources being the thing that actually loads to the GPU ultimately and gets rendered, versus the asset, which is a representation of the thing on disk, like an image, for example. So I hope all that makes sense. I know that was kind of a lot of information to take on board, but yeah. Seeing the Sponza dry is weird. Yeah, so actually, I can show you my ad screen real quick, which I think we just had ads and I missed it. But if we look at this, we actually have water rendering there. So the screenshots don't reflect that, but I took that screenshot and I use it on our ad screen. So yeah, we did add water planes as well. So yeah, that's what our chatter meant by seeing Sponza dry is weird. So that's where we are currently. I hope all that makes sense. This is an interactive stream though, so if you guys have any questions, feel free to jump in the chat and ask. All right. So what we are doing at the moment is we're implementing our resource handler for material resources. And we have it most of the way done, but we have one particular sort of case where our PBR maps are sort of combined into a single texture in memory when we actually load them up. So we can have different resources for metallic, roughness, and AO maps. But as far as when they get loaded up and sent to the shader, they're actually going to be combined as an image in memory, and then sent over that way. And the reason we're doing that is to save on samplers, to save on how much data we have to upload to the GPU, etc. So what we're doing is we're loading up to 3 assets, right? We have a metallic map, a roughness map, and an AO map. And we take the red channel from each one of those, and we put them into a channel of a new temporary combined image. So the metallic map goes into the red channel, the roughness map will go into the green channel, and the AO map will go into the blue channel. And so that's the bit of logic that we're writing now. And our asset loading is asynchronous, or at least it will be when we're done messing with this. And so we're writing some objects here to kind of track that, some structures to basically say what the status of all those different things is, and how to treat them, because all of those disk load asset requests are all separate, right? It's multi-threaded, it happens at different times, and so we have to handle that. And that's what we're in the middle of right now. All right. But does the water reflect? Yes, the water does reflect, actually. But yes, I get what you mean by that. Okay. So we actually can't go by the first image here, the first asset, because the first asset could be uninitialized. So we can have up to 3 map assets. The state of those can either be uninitialized, which means there's no asset for it. We should use the default value. Requested, which means that it's been requested from the asset system but has not yet returned. So it's in the process of loading. Or loaded. And so what we check on this callback, which happens when an asset loads, is to say, hey, the assets that we have here, are they all either uninitialized or loaded, right? Do we have anything in requested? If we have anything in requested, we boot out and we wait till the next asset loads. Otherwise, we will go through and say, well, if we have an uninitialized map, then we'll just use some default values, or if we have it loaded, we will take the values from the red channel of that. And then basically the first one, the first asset that is loaded, we're also going to extract the size information from that, which we won't know ahead of time until the asset actually loads. And that size information will actually tell us how large we need to make the image in memory, right? So we just had it sort of hard-coded here in our temporary code. And so we need to extract that as well. But the any number of these assets can be uninitialized, which means there's no asset to go with them. Theoretically, they all could be. And if that's the case, then technically we won't hit this, and we should probably load a default elsewhere, which I think we can handle in our renderer. But our first one can be uninitialized, and then our second one can be loaded, for example. So we can't just say take it from index 0, right? So I think what I'm going to do is I'm going to switch this to a I32, and I'm going to default these to -1. And that'll basically mean that they're uninitialized, right? And then, well, I guess I could use U32 max too, because we're never going to have an image that big. Let's actually do that. I like that better. So let's say U32 max. U32 max. Okay. So for each one of these, if m state equals loaded, think I'm going to make this a sub if. So I'll say if width equals U32 max, or height equals U32 max, which they technically should both either be set or not set, but I'll check them both anyway. Then we're going to say width equals m asset width, and height equals m asset height. All right. Expression not, oh, missing a double equals. All right, so we go ahead and we get the width from that. And then otherwise, if the width has already been set by something else, then we need to verify that it matches. So we'll say if, I guess we could say, we could do this here. Width is not equal to asset width, or height is not equal to asset height. Right, then at this point, we're going to say k error. All assets for material, metallic, roughness, and AO maps must be the same resolution. I think what we'll do in this case to keep from crashing, right? Because we don't want to crash unless we absolutely have to, right? Let's change this to a warning, and we'll just do a to-do here. Use default data instead, right? We'll throw the asset out and use default data. So we'll say default data will be used instead. So, for example, in the AO map, right, we'll just use white for all of the blue pixels in the image, right? I think that makes the most sense. Okay. Let's see. If the state is unloaded, here we'll do else if m state equals MRA state uninitialized. Then we also need to do this. Right? So if we don't have a texture asset for that channel, or we do have one but it's an invalid size, then we're going to use the default data. Otherwise, we will use the data from that image as we would expect. I think that makes sense. So let's see. We need to think about how we are going to interleave this data, right? Because what we're going to do is we're going to have to set, whenever we load images off of disk, we are flipping them on the y-axis, right? So we work top down because it's easier to think of images top down. So our RGB pixel data that we're going to set up, our combined pixel data, is going to be top down as well, right? So in this case, what we're going to do is once we have the width and the height, we're going to go ahead and also create the pixel data here. So let's create our U8 data here, and we're going to say, let's just call this pixels, right? And we're going to default that to 0. And then when we get to this point, we're going to say pixels equals k allocate size of U8, and that's going to be times width times height times 4 for RGBA, right? Now, technically, we don't need the alpha, right? We could skip that, but most of what we do is an RGBA anyway, and chances are there might be another map or some other value that we could store in this, in the alpha channel. So we're going to go ahead and just create it with the alpha channel. Memory tag, let's go with resource on this one. Thank you for the follows, I appreciate that. Welcome. Welcome, welcome. I appreciate the follows. All right, so we have our pixel data created here. And then actually, since we have this particular data loaded, and we have the width and height set up here, I suppose we could actually just go ahead and we're going to have to load the pixel data in another pass. Come to think of it. And the reason for that is because we are iterating these maps in order, right? But if we get, let's say, to the second or third map before we actually know what the size of the map is, we can't actually have loaded the map for the previous images yet, right? So we're going to have to like start over and do another loop, which is not a huge deal. We're only looping over 3 of them, right? So we'll do that, and we'll also do the verification for this. Now, if we have a situation where we're going to use default data, then what we're going to do is, in order to trigger default data, we are going to say k asset asset system. Really? Do I not? Why is my... Don't we have... Yeah, release. Oh, it's asset system release. Okay. System release. We're going to release the asset first. So we're going to just do engine systems get asset state, and then we're going to release the asset name, which we do have, right? So that's going to be k. Oops, I'm sorry, m image asset name and m image asset package name. That's right. So we're going to go ahead and release that asset. We don't need it anymore. Thank you for the follow. Appreciate that. Welcome. All right. So we release the asset, and then we are going to say m asset equals 0 and m state equals MRA state uninitialized. All right. So what we'll do is we'll say use default data instead by releasing the asset and resetting the state. All right. So we'll do all of this. And then we technically don't need this case here, but we do need it in the next loop. So let's take this and do one more loop. So in this case, we're not going to have to check. The only thing we need to check is for loaded, right? Loaded or unloaded. Or loaded or uninitialized, rather, right? At this point, pixels should exist. I suppose we should probably check for that anyway. Right, so if not pixels. You know what, actually we should probably do that here. If not pixels. Pixel array not created during asset load for material. This likely means other errors have occurred. Check logs. Right? If that's the case, that's a hard error. There's not much we can do about that. Okay, so if we get here, we're going to iterate the assets one more time. And we're basically going to just check these two states, right? And we're basically going to say, and we're basically going to loop through the pixel data and either extract the pixel data or use default data, right? So I guess default data is probably going to be the simplest one to do, right? So let's do a switch, and we're going to do this based off of channel, and we're going to say case. What was this? K asset material map channel. And we're going to go with metallic first, right? Break. So let me think about this for a second. So we have, are you using a Ducky keyboard with Cherry MX Blue? No, I am using, I've got this cable managed kind of tight here, but I think you might be able to see it. A Keychron K2, the 65% version. I think, let me see if my new bot command works actually. Yes, it does. Yeah, so it's the Keychron K2 65% wireless keyboard. The RGB version. Mine is just red, set to red right now, but yeah, it's a phenomenal keyboard. I love this keyboard so much. It's nicer feeling than all my other keyboards that I've ever had. And before this, I used almost exclusively Corsair keyboards. But this one is just fantastic. Yeah, it's a really, really good keyboard. I'm super happy with it. And what's nice about it too is you can either use it cabled, plugged in, which is what I have right now. But then there's also up to 3 Bluetooth channels that you can use with it. So you can hook it to different devices and just hit function 1, 2, or 3 and switch between devices. It's freaking awesome. And it also comes with keycaps and a binding switch between Windows/Linux and Mac OS. So you can actually just flip a switch and you get the correct, option key and all that stuff. It's a really fantastic keyboard. Very well designed. Thank you for the follow. I appreciate that. With the K prepended to everything, it looks almost like kernel code. That's funny, Raz. How's it going, by the way, Raz? It's good to see you. Yeah, I started prepending K to stuff because I didn't want to have naming collisions on stuff. And so it also makes it a little bit easier for me to tell what's new and what's old. Because eventually, K will be prepended to most of our types. All right. Okay, so our default data is just going to be a. I guess we could define a vector for. Do we? No, we don't even really need that, right? We only care about 1 pixel of data at a time. So really, we just need a U8, right? And then we'll just say channel value, right? And so the default for a metallic what did we say that was in the texture system when we create default textures? Diffuse, specular, normal, combined. Here we go. How convenient. We have our default values right here. So I suppose we could actually just grab... We could just grab this loop, right? I don't want to check. Yeah, I think the way I'm going to do it is per. I think I'm going to loop within the case, not loop outside the case and then switch inside. That seems like it'd be a lot slower. All right, so the dimensions here we have to use width, or let's see, we want to do height then width. Channels is going to be 4, always. And combined pixels is just going to be pixels, right? So that's going to be, what, 9x? Yeah. Okay, so I guess what we'll do is we'll count metallic as default as well. And we'll loop through the image. We'll do, let's see, this needs to be width. Okay, and then the only one that we'll need to set is that top one, right? So we'll just set a default for metallic, which is black. And then we'll break, and then we'll copy pasta this. This is kind of repetitive. I'm not a huge fan of it, but it's going to be the most clear to read, I think. So let's do roughness next. And that is going to be that one. Ruche, thank you for the Spiro emote there. Yeah, no problem about the keyboard. Yeah, I'm not sponsored. I mean, as much as I advertise this keyboard, I probably should be sponsored by them. I'm not, but that's just how much I love that keyboard because I'm always singing their praises. I probably should be sponsored by them. I probably sold a lot of them, but it's fine. Okay, so we'll just do one last one, which is going to be AO. AO. Right, and that's just going to be that, right? So we can remove this dead code, remove the dead code, remove dead code. Okay. So that's how we set the default value, right? Now here we've just got the value hard-coded. So the only difference between this logic and what's going to go up here is where that data comes from, right? So we're either going to be sampling the assets image data, or we're going to be sampling just a hard-coded value here. So what I'm going to do, believe it or not, is let's see, we don't need this channel value thing. And this is no longer a to-do. so that's the default data. And then we can take this and put it here, right? But instead of using default data, we'll do asset pixels, right? And then this is also going to wind up being, because we have the dimensions, index BPP. And I'm going to put the +0 in there to make it a little bit clear. Like ads are clear right now, because I'm paused for them a little bit late. But I still caught it. So I'm not going to wait for that whole timer to count down. But if you guys need to go grab something to drink, go for it. Because we still have, realistically, about 45 seconds left. I'll wait a few seconds longer. No problem, Coffee Lava. I know you hate missing content, dude. Yeah, it's your pet peeve. You hate that almost as much as... Well, all right, I'm going to ask this instead of assume it. Do you hate it as much as ECS? Or do you hate ECS more? Which one is it? I'll wait for your response. It's a good question, right? All right. Ads are dead, so I'm just going to cut the timer a little bit early here. All right. So we are going to pull from the red channel. All right. And actually, I just thought of something. This is actually, like, I could simplify all of this actually a lot. All right, so what we should do here, we should have like a, I guess a U8 offset, right? And we'll say 0. This offset equals 0, right? And then offset equals 1. And then offset equals 2. Right? And that way we can take all of this crap, since we're always pulling from the red channel. You just have one loop at the bottom. And use offset here, but not here. Right, so we always want to pull the red channel from the texture, but we want to put it into the offset channel of the target texture, which means we can get rid of all this and all this. Oh wait, there was a bit in there I actually do need. Oh, I'll need that for the default, but for this will be fine. Yeah, okay. Yeah, okay. So for this, it won't actually matter. All I should need is that. Okay. For the default, we can do something similar, right? So I can actually just grab this here. Oh, I need a U32 offsets equals 0. Right, so we have the 0 there. Right, this one is 2. This one is 1. And then we do want value, so we'll say U8 value equals 0. So in this case, we want value equals 0, right? And I'm actually just going to copy this guy. Thank you for the follow. I appreciate that, and welcome. Oops, not there. I want it there. All right. So we can do value equals 128. All right, so we'll put that there. And then down here, value equals 255. Right, and so default for AO is white. Right, and then what we can do is we can take all this stuff out of here, put one of these at the bottom, kill these other loops, do offset here, and value there, and there we go. Fishimus over on the YouTube side, thank you very much for the sub. Appreciate that. Welcome. Have you looked at STL3 GPU API? I have not. Was it any good? Last time I looked at STL3, it was still very much in beta, so I've not looked at it a lot. Is it pretty powerful stuff? And how is it with 3D? Or is it like not a... It's similar to Vulkan, really. Is it like, I guess, is it similar to like Web GPU / Metal also? Cross-platform? Yeah, because I used to say that Web GPU was like Vulkan, but it's really more like Metal. They're also making a unified shader language, which is one thing that I'm going to have to do with this, for sure. Probably to compile into SPIR-V. I know DirectX 12 eventually is going to support that. I don't know how far out that is. So that's pretty cool. But yeah, eventually I'm going to have to write a shader language that sort of translates into SPIR-V, and then HLSL, and then is it MSL for Metal? I can't remember. Yeah, we're definitely going to do that. I think as a challenge, we're going to just do that. We're going to write something that translates to all three, and it might like only support like a subset of it, but that still I think would be pretty awesome. Because like I'd have to choose features that are available on all three in order to make it work. But I still think it would be a pretty awesome exercise. Okay. Okay, so default data. I think this is everything we need for the combination of that, right? So this pulls from the red channel. And if we use the default data, it pulls from just these default values. Okay, so now we have our pixel data, right? So we figured out the size, we figured out how much memory we need to allocate. We've got our pixel data. The pixel data is filled out. Now we can actually do all of this stuff and actually get it uploaded to the GPU and sorted, right? So let's see. Listener target map texture. Okay, so listener target map doesn't exist anymore. What we're really looking for this target map is actually going to be not what we don't actually need that there. This target map is actually belongs here. And target map is going to be metallic roughness AO map. So that exists there, which means down here, where we are actually setting that up, we need to do that outside of this, like right after we create the listener, I guess. So right here. So let's take this and change this out to be listener instance target map. Instead of that, it's going to be metallic roughness AO map. All right. And then this is going to be metallic roughness AO map texture, which is not going to have a texture, but I suppose we should check it anyway, right? Okay, so this is going to be metallic roughness AO map. And let's see, we have listener map repeat. Okay. So this is another thing we need to change, actually. So what that listener map was a reference to is it's actually a reference to this guy, which we also only need one of, because it's combined, right? So we're going to do, let's do metallic roughness AO map config is what we'll call it, right? And what did I do? Okay. So we'll do metallic roughness AO map config. Oops. So that's where we get our repeat, our minify, that kind of stuff from. I'll also need to come down here and modify this further down here as well. Let's see. I guess what we can do, I guess we could just take that. But instead of M, it's going to be listener instance map. And it's going to be metallic roughness AO map config, right? So what we're going to do is we'll just use the map config for the first one of these, right? Even though technically these will all be configurable separately, they're not really going, it's just going to use the configuration of the first one that actually happens to occur. We may eventually wind up switching that, but for right now, I'm not bothered by it. Most people are probably going to use the defaults anyways. All right. What has happened down here? I don't know. Did I do a stupid down here somewhere? Must have been a while ago. All right, I'm not going to worry about it. All right. I assume, is that the load failure? Chaos at unresult. Do I have an extra brace in here somewhere? It's kind of looks like. Maybe it's this. Let's see, that switch, that's for that one. I feel like I'm missing a brace in here somewhere. Yeah, because what does this one go to? Switch on the asset type. Which that should be this. So what does this one go to? So wait, does that mean I'm missing one or I have an extra one? I'm missing one. Right? Yeah, there we go. Okay. All right. Okay, so we copy over all of our map properties, and then here's where we actually acquire the texture map resources. This is bleating about the typed resource base name, listener typed resource base name. Okay, so let's see. This. Oh, we don't have a typed resource in the listener, do we? We need to add one. Right. Okay, so this is going to be K resource material typed resource. And then I'll bet that works. What map? Oh, this should be, instead of map, it should be listener instance metallic map.ao config. It was listener instance, right? Oh, listener. Okay. And this one should be that. There we go. Okay. That's left over from some copy pasta that we did before. Let's see. Move this to asset load callback. Okay, that's done. That's where we are right now. Thank you for the follow. I appreciate that. Welcome. Have an extra brace on the... Oh, yeah. I was missing a brace, actually. I hate when that happens because it's hard to figure out sometimes. All right, so here's the name. So that's the resource type. Okay, so this is the creation of the texture, right? So what we do here is, in order to load this pixel data, we create a writable texture. So let's see, map name is generated here. Okay, so that makes sense. The next thing is these are hard-coded, so this needs to be width, and this needs to be height. And then texture format RGB8 is what we're going to use. Even though we're not using the A right now, we eventually will. This code's set up for it. And then we go ahead and free that. And then we go ahead and... Wait, why do we take the map name again? Why do we do this twice? Yeah, we don't need this twice. Okay. So we create the writable texture, and now we need to actually upload the data to it. So texture system, write data. The texture is going to be listener typed resource, and then the offset is going to be 0. The size is going to be width times height, I think. I don't remember if we need the channel count for that. and then pixels. Let me see if we needed the number of bytes to be written. Okay, so we have to go with, you know what, we've already computed this once up here. So why don't we save this off? So we could just, whoops, so we could just reuse it, right? So we'll do U32 pixel array size equals 0. And then we'll do this pixel array size equals that, and then pixel array size. And then down here, we can do pixel array size. Now, why is this bleating? Incompatible pointer type. Cave resource material. Oh, the texture. Dingus. It's the listener, not the typed resource, but the AO map texture. Oh, that's a constant. Because normally texture resources are constant, right? Which just means that we shouldn't be writing stuff like the size and then properties like that, right? But we could safely cast the constants away here. I'm not a huge fan of doing that, but okay. The other thing is this returns a Boolean. So let's check to make sure that that's successful. If not, failed to upload combined texture data for resource, material resource. We'll just put this in quotes and say listener typed resource base name, and from that we'll have to do a kname string get. Okay. And I guess what we could also do, right, we'll boot out here and we'll change this to a ktrace and we'll say successfully uploaded combined texture data for material resource, blah, 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 blah. And then we're done, right? So this is going to be a lot more flexible than what we had before, because what we had before required us to manually go in and create these assets. So for example, if I take a look at the resources, not runtime testbed. Take a look at, let's see, combined. I want the source. So here we go. So for the chain, well, that's probably not a great example, but let me see if I can find a better example. Like this texture contains metallic roughness information, right? And it also contains AO information, right? And so that we had to manually create these files in either a photo editor, or we have technically an external little utility that will take separate maps and combine them together. But the way that we have it now is that we can actually feed in the individual textures for, like metallic roughness, and these are targets, so I guess this editor isn't going to support those, but we could take metallic roughness and AO if we have it, and feed those in, which would be nice for an editor, right? Because then we can swap them out on the fly and stuff like that. We may wind up eventually supporting multiple resolutions or different resolutions simply by maybe like blitting the data somehow onto like the right size texture and then moving that pixel data in. But I don't want to set that up right now because that's a little bit more complicated. I want to get sort of the baseline version of it working first. And I don't think we have any errors in here. So let me just get rid of some of this dead code that's in here. We do need to think about hot reloading at some point, but we're not going to tackle that until we have everything converted over. I think we're good. All right, so this is going to handle resource loading for materials. I think we should be good. Trying to think if there's anything else I've missed. All right, so let's go to resource system. And we want the K resource system this time. That's the new one. And we have to register this, right? Because we've created it, but we haven't actually registered it, right? So we basically just need to follow this process for all the known handler types, right? So this is the texture handler, right? And actually we can scope this out, right? And it'll just make it a little bit nicer, right? And then we don't have to keep like writing different types of handlers. We could just rename this to handler. Okay. So let's take this and we'll say material handler. And this time it's going to be, we need to include the file first actually. So I'm going to copy that line and I'm just going to replace this with material. And down here, we can just say, let's see, material, and then K resource type, material, and material. Cool. So our material handler will now be registered and able to handle those types of assets, which is awesome. So I believe we set up everything we needed to in our material system, I think. No, we did not. I think we got to the point in our material system where we're like, oh, how do we actually load materials? And we had to kind of sidebar from that. Right. Okay. So this was, yeah, that's why we stopped here. So our material system was doing all kinds of stuff. It was reference counting, right? Which this can go away. It was reference counting. It was the thing that was owning all the materials, the material resources, I should say. It was handling reference counting, the hash table lookups, all that kind of stuff. And now all that stuff is now pushed off to the resource system, right? So the resource system owns everything, and ads own us. Few seconds late on that, but it is what it is. Let's see. Is this a game plus engine or pure engine? So for right now, it's a pure engine. I'll repeat that question actually once ads are finished. Just in case you can't hear me. Just respond to that. All right. I got some YouTube chat to catch up on, looks like. Have I heard about the drama going on with Godot? Yes, and I'm not touching that with a 10-foot pole. Yeah. Nope, not even going to talk about that. Yes, I'm very aware of it. It's unfortunate, all the drama that's going around that, but I hope they straighten it out. That's as much as I'll say on it. Let's see. Me, Mr. Mustard. Kohi had one the other day. I accidentally said the word code after accidentally saying the letter S after accidentally saying the letter V. Canceled for a month. Yeah, it's a bit of an inside joke, Raz. It's not something that we It's not something we're ever serious about. It's just kind of a inside joke for sure. So the joke is that we say we're a family friendly stream, and then whenever I say, VS, I bleep it. That's it. That's all there is to it. Yeah, it is a great engine. It's just, it's one of those things, and they are not quite sticking to the no politics thing. I have a strict no politics discussion here on my Discord server. No politics truly means no politics, right? So we don't discuss that stuff. This is a platform to discuss game development, and that's it. We stay clear of all that stuff because you're never, ever going to have everybody agree on it. That's okay. It's just not the platform for discussing that kind of stuff. And I intend to be very strict and stick to that. But yeah. Yes, it is far. Yeah, I agree, Dav. But yeah, it's definitely not something that we're going to get into here for sure. Maysaka, thank you for the follow. Appreciate that. Welcome. Yeah, so to your original question, this is a pure game engine for now, but we are going to be starting a game in the next, I want to say, month or so. We're doing a little bit of refactoring in terms of how resources and assets are handled in the system. So, yeah, that's what we're working on at the moment. Okay. So I think when we left off here, we were still kind of getting like clobbering some of our old material management code, um, which a lot of it was actually like getting actual resources and like doing parsing and stuff, which is totally not what we should be doing in here. And I believe we can actually get rid of like all this load material stuff. We don't actually need that stuff anymore. Pretty sure I can go from here all the way down to here. And not quite collaborate because I've got block comments in here somewhere, apparently. Where? It's got to be down here somewhere. There it is. Let's just change that into this. Can't wait to get to the game part 3. Wait, can't wait to get to the game part. 3 years. Wow, it's been that long seeing this engine evolve. Yeah, I mean, game engines are definitely not for the weak, right? Let's see. I like to say I'm making a game from the engine up, but my effort is something like 80% engine, 20% game. Yeah, and that's probably what we're going to be in the first couple months when we actually kick off the game project itself. Is it's probably going to wind up being about that ratio as well, and then it'll gradually shift to being probably 100% game or close to 100%. Yeah, that's fair enough, mean Mr. Mustard. I'm not going to read that on stream, but yeah, I can't disagree. All right, Raz. See you later. Have a good one. All right. Let's just convert all of these over. I think all this code is dead anyways. I don't think I really have to worry about this, but I'm keeping it just until we confirm that all the new stuff works, and then we'll get rid of it, right? Destroy material can also go. So this is another great thing. I get to delete a bunch of code, which is awesome. All right, create default PBR material. So this is going to be a little bit more involved, but it shouldn't be too bad, I don't think. What we basically need to do is we need to trigger, well, let me think about this. So we've offloaded the creation of materials from the material system over to our resource handler, right? And I'm just going to fix my hair while we do this, while we talk about this. So we've offloaded that from, out of this file. Now, the advantage to that is that we can remove a lot of code in terms of, having to do with material creation. A lot of that stuff can be moved out of here, which is great. The not so great part is that it makes it a little bit more cumbersome to do something like create a material in code. And so I think what we might need from our resource system, we might need to tweak our resource system a little bit to say, let's create a resource from some configuration or code and just register the already created resource, right? And just pass that off to the resource manager and let it handle it, right? And so my thought is there's two ways we could accomplish that. We could either just create it in code, which would mean that we would have to duplicate all that stuff about getting assets, loading textures, all that stuff. Or right? Which is not great. I really don't want that like polluted all over the place, right? I really want that like handled by the resource system. I want it to sort of own all that stuff. Or we could, instead of loading an asset for a resource, right? Maybe we pass it the asset data or the configuration depending on the particular type of resource. And we say, hey, I want to request a resource of this type, but here's the data that I want you to use. Now we can already kind of do that with textures, right? Because we have a way of sort of passing that through, right? We can do it with like pixel data, for example. So I'm thinking with materials, it's going to be a little bit different, right? Because our material files, if we take a look at, let's see, I think I started converting some of them. Our material files look like this, right? And so if I were to create a default one of these, it would essentially have to be probably a block of text, right? That was formatted this way. And that would have to be stored somewhere in code, and then we basically just pass off that string. And then that would be essentially the asset source, and then we'd go from there. Because what I don't want to do is I don't want to have our default resources reside on disk. Our default resources are like our fallback for cases like where we try to load a texture and we don't find one, we use a default texture. If we try to load a material and we don't find one, we load a default material, things like that. And I don't want those things to be required to be on disk, right? Because ultimately, I don't want you to like be loading this thing up, and the runtime has like on disk requirements of assets, right? It should be able to generate at least some sort of default, some sort of same default in code, so that you never have to say, well, every game I create has to have this bucket of assets that goes with it because it's part of the engine, right? That's rubbish. We don't want that. JRF, how's it going? First time chatter, welcome. Let's see. So I guess if we take a look at our K resource system, if we take a look at the interface for this, we have our request here, our request info, right? Which I suppose we could expand our material request info to include the extra data that we need. Actually, that's probably how we're going to handle that. That's what we did for textures. I think that's what I'm going to do for materials. Right, so remember when we created this request info that we basically said that it has just this base data and nothing else. Well, we're going to add to it, right? So we have the basic K resource request info stuff. But we also need, let's see, how do we want to do this though? I suppose the simplest way would be to just provide a string, right? So we could do a string that we would call maybe material source text, right? And this would be optionally include source text to be used as if it resided in a KMT file. So we have material system acquire. So what we would do is when we create our default PBR material, right, we would essentially do this. Now, obviously, the return and all that stuff doesn't need to be done. But I believe what we can do we can get rid of all of this stuff. Oh, wait a minute. You know what? I don't think we have some shader stuff here that we actually need to do. I've got to pull that out. Okay. This stuff doesn't need to be done. This can go away. I think, though, instance resource config. Yeah. Okay. So we can get rid of this, right? And then we're going to say, fix me. Move this material shader acquisition code to somewhere else. Or maybe it should be up to the material system to handle this. I don't know. We'll have to figure that out. But ultimately, as far as actually loading the resource goes, this is all we should really need to do. So we should go request material source text, right? Equals, and then whatever. Now, wherever that text comes from is where it comes from, right? We can take a, let's see. Let's do, I guess we can take this as our example, right? And we can just paste it here. Okay. So we'll do the ugly backslash thing. Right? So we're basically just going to have to, let's see, maps. I'm going to say we should try let's try using default diffuse, right? So we'll escape all of this stuff. I'm not really a fan of doing all of this weird string stuff in code. I'm not sure that I'm going to leave it this way. Oops. But again, I don't want the runtime to insist on having assets on disk. That's the whole reason we're doing this. Right? These properties, those can go away. We don't need properties, right? I'll keep the array, but, and then we'll end the string here. right? And so what that'll do is that'll allow us to say, hey, I want to load a material, and then here's the configuration for that. And then in the let's see, the name, we can go with I think this wants a K name, right? Yeah. So we can do K name create material name. Thank you for subscribing over on the YouTube side. You left a quote out at the beginning of albedo. Did I? You're right. I escaped the A. Thank you for that. That would have been gross to find later. Do we not have default material names? I guess we don't. Let's go with default. Okay. Okay, so out resource, instead of out resource, we're going to do state default PBR material, right? And then we don't need this. And that should be all there is to it. Why is this? Oh, right, because I've got to cast this. There we go. Okay. So, aside from the shader configuration, which is done here, which we're going to have to tackle in a second, this should all be all that's needed, actually, to create like a default sort of material. Right, so I can say default diffuse here, default combined, and then maybe default normal, right? And I probably realistically don't even need these maps. I could probably just use the defaults, right? In fact, I'm going to actually try removing these two and just leave that one in there as an example and see if it loads correctly. And if it does, I might just be able to do that, right? And just be like, this is our default PBR material, right? And then just have this be the only thing that really matters. I guess that's gonna really be it. I can't think of any other things that we need to do. Okay, let's see. Set up a configuration to get instance resources from the material. So, instance resources. Something that has to happen with the shader. The shader needs to know about what instance resources to acquire. Now, instance resources, in terms of Vulkan, is descriptors, right? So when we go to acquire this, the reason that we need to know about all of these texture maps is we need to know how many descriptors we need, right? So we have 3 scopes in our shader, right? Scope is basically how often a descriptor gets updated. So there's global, there's instance, and then there's local. Local is not actually a descriptor, it's a push constant as far as Vulkan's concerned, right? So realistically, we have 2 scopes of descriptors as far as Vulkan's concerned for shaders in general, right? We always have just the global, which is basically updated once per frame, and the instance, which is updated once per, you can think of it as a material instance, right? So if you have, let's say you have a scene that's got a tree texture that's used twice and a metal texture that's used twice, right? I shouldn't say texture, I should say, material, right? You have two objects that use a wood material, two objects that use a metal material. So to draw all four of those objects, you would update the global descriptor once. That contains like your projection matrix, your view matrix, things like that. And then you would set your instance level resources, or your descriptors rather, once per material instance. So even though you're drawing two objects that use wood and two objects that use metal, you still only have one instance of each one of those, right? So there's one instance of a wood material, right, which is a instance technically of a PBR material, and then you have a metal material, right? So the instance would be applied twice, and you would have two instance resources in that case, right? And so within those descriptor sets, you have descriptors themselves. So we have one descriptor for our uniform buffer objects. So that's like all of our different uniforms that we have in there. And then we have one descriptor per texture map that we have, right? So, in our PBR, we have a global descriptor, and we don't have any global images, right? And then we have a instance UBO, right, which is an instance descriptor, and then we have several samplers or texture maps, right? And so we need a descriptor for each one of those because we use combined image texture samplers, right? So that's the reason that we need to know all this. Is just to know, so we know how many of those to get, right? So when we acquire texture map resources, that's acquiring samplers, right? Which could be used with any shader. But when you're acquiring instance resources, that's resources per instance of a material. You can think of it that way, right? So that would be once for wood, once for metal, for example. So I'm just trying to think of, before, the way that we did this was we have how many uniform configs we have, which actually the name is a little bit misleading because it's actually texture configurations. And in this case, it's 3, right? So we have the material maps, which is a array, right? So that's a sampler array. Then we have shadow maps, which is another sampler array. And then we have an irradiance map, which is just a cube map sampler, right? And so this is what is setting that up to tell the renderer what we need. And that is the reason that we need all of this stuff here. Let's see. So I think half of the errors here are just because we changed from state pointer to state. But then we also have default PBR material. This probably is just needs an arrow operator, maybe. Do we not have internal ID? I don't think we do have that anymore, because that's a K resource material. So instance resources requires a pointer to hold a instance ID. So whenever we acquire instance resources, we have an ID associated with that. That is a lookup into an internal array within the renderer, so that we can grab the correct instance resources for that given shader. We do not have that stored in material right now. Before we called it internal ID, but I think we ought to call it instance ID. And we'll need to add that to the material. I was thinking about separating that out. But now I'm not really seeing any reason for doing that. Other than ads. Looks like we have a spammer here. C++, it's C, actually. Oh, geez, another spammer. Okay. First time chatter, by the way. Let's see. First time chatter, welcome. I need to learn Vim, actually. Yeah, I highly recommend it. I recommend most people give it a shot, right? It's not for everybody, but... Let's see. Almost done with ads. All right, cool. So just in case you weren't able to hear me, C++. No, this is C, not C++. Need to learn Vim. Actually, yeah, I highly recommend people learn Vim, or at least give it a try. Apotham, how's it going? Wait, what? Update and shutdown actually worked on my Windows 11 PC. I think that's the first time it's ever happened. Even happened. Did you see the YouTube short that I put out for that? Let me... grab it real quick. I'll link it so you guys can watch it. Let's see. Yeah, it's pretty much every single time Windows updates come out. That's essentially what happens. So if you guys want to, you want some entertainment. I mean, I suppose I could play it on here, but I don't think the sound is going to come through. So. Anyway. Yeah, I thought it was pretty good. I was pretty proud of that one. Yeah, it's accurate, right? Yeah, I just hence why, Arch, by the way. Okay, so U32, we're going to call this instance ID. Because all materials are going to be associated with a shader of some sort, right? Generally, the material shader, right? Or one of our material shaders. We're not going to have like I guess if we have a custom material, we'll wind up having a way to apply that as well. But like we're not going to have one material that could possibly go to different shaders. Like that's not the way that's going to work. All right, so we'll have an instance ID. So instead of saying internal ID like we did before, we'll be more accurate and we'll have instance ID. So I guess for now, this is what we're going to go with. I'm still not 100% happy with this, but I'm going to try and see how this runs with it first, and I'll just leave a fix me in there. Make sure to sign the shader ID. I don't think I need to do that. That can go away. Okay, default terrain materials. So terrain materials are something different entirely. Terrain materials are basically it was a sort of specialized material that that links multiple materials together, right? So it is basically allows us to layer materials, right? So I think we're probably going to have to tackle that on the next stream, or I might even tackle that offline, just because that is not something we're going to get done in a couple minutes for sure. 69 though. Yeah, you saw the error code. What's funny is the BSOD generator that I used had that in there by default. It's funny. All right. So yeah, I think that's going to do it for tonight. Thank you guys so much for being here. I really appreciate it. If you haven't already, I would really appreciate a follow and or subscribe, depending on which platform you're on. It helps me grow the channel, and I'm trying to reach more people and trying to get people into engine development, and one way to do that is to let people see what goes into it, right? So that's what we're trying to do here. We're trying to motivate more people to get into game engine development, because I figure that will spawn more competition, right? Which is always a good thing, that pushes things forward. So with that, thank you guys for being here. I'm going to choose somebody to raid really quickly. And let's see. I want to see if I can find something that is kind of related to what we're doing, if I can. Let's see. I see a couple of options, actually. I just want to scroll down and see if there's anything. Let me actually do the same category real fast. So I think the one we're going to go with yeah, okay. We're going to raid Hypnotic Games. I'm not sure what let's see, what's he working on tonight? He's working on a traffic jam simulator game. Should be interesting. So yeah, we're going to raid him, see what he's up to. And yeah, just thank you guys again for being here. I really appreciate you guys. And we will catch you guys next time. So see ya.